Imagine this. You're running a business. Maybe it's thriving, or perhaps you're a lead developer,
Yeah.
right? And you've built this great web service, an online store maybe using Spring Boot. It's working well where it is now. But suddenly, demand just goes through the roof. You need to handle thousands, maybe millions of users, all smoothly. You need it always available, and you need to do it without spending a fortune or getting tangled up in server hardware. How do you actually make that leap from, local success to a global scale? Well, that's exactly why we do the deep dive. It's about giving you that shortcut to being really, truly well informed on these kinds of critical topics. So today we're diving deep into moving Spring Boot applications over to Amazon Web Services, AWS. We're talking about taking that solid Java-based app, could be a website backend, could be microservices, taking it from wherever it lives now
Mm-hmm.
and moving it into the powerful world of AWS Cloud.
Yeah, it's a pretty common scenario these days.
So at its heart, migrating, it just means moving your Spring Boot app, the code, the data, configuration, all of it from, say, your company server onto AWS. And our mission today, it's to unpack not just what this means, but how you actually do it. The really compelling benefits, what problems it solves, those old headaches, and why this skill is, well, absolutely vital in 2025. Let me try an analogy here. Think of AWS as like renting this huge professional kitchen, infinitely scalable, available everywhere.
Yeah.
Your Spring Boot app, that's your signature dish, right? Perfected, ready to go. Migrating it is like moving your whole cooking operation into that amazing kitchen. AWS gives you the ovens, the storage, the prep space, even helps manage things.
Right, the infrastructure.
Exactly. So your dish is always perfect, served to anyone, anywhere. So how do we actually start moving that kitchen setup?
Okay, let's unpack this then. What are the core pieces involved when you decide, right, let's move this Spring Boot app to AWS? Yeah, it really boils down to, I'd say, four main areas. First, obviously, is the Spring Boot application itself. That's your Java code, the logic, could be a website, could be an API.
Mm-hmm.
Then you've got its current environment. Where does it live right now? Your laptop, an old server, maybe even another cloud.
Okay.
Third, you need to pick the right AWS services. These are like the specialized tools in that kitchen we talked about. EC2 for servers, RDS for databases, S3 for file storage, or Elastic Beanstalk to make deployment easier.
Right. Lots of choices there.
Definitely. And finally, there's the migration process itself. That's the actual sequence of steps, moving code, shifting data, setting up the configurations on the AWS side.
That separation between the app and where it lives, that's really key. But okay, this migration process, is it always this huge disruptive rewrite? Or can it sometimes be simpler?
That's a really good question. And it's a common point of confusion, actually. It doesn't have to be a massive overhaul. Generally, you see two main paths. There's what we call lift and shift.
Lift and shift.
Okay. Yeah, basically moving the app pretty much as is. Minimal changes, like just moving your existing kitchen gear into the new space.
Gotcha.
Or you can go for a re-architecture. That's where you actually modify the app to really take advantage of AWS features. Think serverless, maybe breaking it into microservices if it isn't already.
Ah, so that's more like redesigning the whole cooking process for the new kitchen.
Exactly. The choice.
Oh.
It often comes down to your goals,
Yeah.
how much time you have, what you want to achieve long term.
That makes a lot of sense. Okay, so let's say we've looked at our app, we've picked an approach. For someone starting out, what are the actual steps? Walk us through how they do the migration.
Right. It's a pretty systematic process.
Yeah.
Let's imagine we have a startup, call them SwiftShip Logistics. They've got a Spring Boot app for tracking packages.
Okay, Swift ship, like it.
So first, SwiftShip needs to assess the app. They look at its pieces. What database? MySQL, maybe. What server?
Hmm.
Embedded Tomcat, perhaps. Any external things it depends on.
Mm.
This helps them figure out what AWS services match up. Next, they choose AWS services. If SwiftShip wants easy, Elastic Beanstalk is great. It handles a lot of the setup and scaling automatically.
That sounds beginner friendly.
It really is. But if they need more control, they might choose EC2 virtual servers. For their package database, RDS is the obvious choice, managed databases. And maybe S3 for storing like scanned shipping labels or something.
Okay, so Swift ship knows what tools they need from the AWS kitchen. What's next?
Then they prepare the app. This means tweaking configurations.
Uh,
For SwiftShip, that critical step is changing the database connection details to point to the new AWS RDS database, not their old one.
right, got to point it to the new address.
Exactly. And they package the app, usually into a JR file. Then they deploy the app to AWS. Elastic Beanstalk can automate a lot of this. Or, if they're using EC2, it's a bit more manual. Maybe they use Docker containers and deploy to AWS ECS.
Okay, deployed. What else?
This is super important. Migrate data. All that existing customer info, the package tracking history for Swift Ship, it needs to be moved securely to the AWS database, like RDS.
Can't forget the data.
Absolutely not. Then, rigorous test and optimize. Swift Ship needs to check everything on AWS. Does login work? Can users track packages? Is it fast? They'll tweak scaling settings here to balance performance and cost. And finally, monitor and manage. They'll use tools like AWS CloudWatch to watch performance, see how it's being used, set up alerts if anything goes wrong, keep that Swift Ship tracking reliable.
That is a really clear roadmap. The Swift Ship example helps a lot. But let's get to the really exciting part for businesses. Why bother with all this? What are the huge game-changing benefits?
Oh, the benefits are pretty profound. They touch everything: development, deployment, how you run the thing day to day. First off, scalability. This is huge. AWS lets your app grow or shrink based on demand automatically.
Like the holiday rush for Swift Ship.
Precisely. Imagine that massive spike in package lookups. AWS can just add more power instantly to handle it, then scale back down when things calm down. No crashing, no slow responses. And you only pay for that extra power when you use it.
Which leads nicely into the next point, I guess.
Exactly. Cost efficiency. Instead of SwiftShip buying tons of expensive servers up front, paying for electricity, cooling, staff, they use AWS's pay-as-you-go model.
Renting versus buying the whole building.
Perfect analogy. You rent just what you need. Now, what's interesting here is that while the promise is efficiency, sometimes companies actually overspend at first.
Oh, how so?
Well, you need to learn how to manage those resources smartly. There's a whole field now called FinOps Financial Operations for Cloud. So true cost saving isn't just automatic. You have to actively manage and optimize. It's an earned benefit.
Right, requires some discipline. Okay, what else?
Third, reliability and availability. AWS has data centers all over the world. So SwiftShip's app can be set up so even if one server or even a whole data center has a problem.
The app stays up.
Exactly, it fails over. Your Spring Boot app is accessible 24/7, anywhere. Critical for something like package tracking. Fourth, simplified management. AWS handles the annoying stuff: server upkeep, OS patches, security updates.
Stuff developers don't really want to do.
Generally, no. For SwiftShip, using Elastic Beanstalk, AWS manages almost all the server setup. Their developers can focus on cool new tracking features, not fiddling with infrastructure. It's also surprisingly beginner-friendly. I mentioned Elastic Beanstalk. Tools like that genuinely make it easier for new developers, maybe someone just joining SwiftShip, to get an app running in the cloud without needing to be a deep AWS expert right away.
That lowers the barrier to entry quite a bit.
It does. And
Yep.
finally, integration with modern tools.
Yeah.
AWS works beautifully with the whole Spring Boot ecosystem: Spring Data, Spring Security, all that. Plus, it fully supports things like Docker containers and Kubernetes for more advanced deployments. It fits right into modern development practices.
Those are some really strong arguments. But thinking about someone just starting out, a developer or maybe a small business owner, what's a common hurdle? Something that seems easy but might trip them up.
That's a crucial point. A common misconception is thinking that lift and shift is always the simple, cheap answer and you're done.
But it's not always.
Well, it's often easier to start with, yes. But the real deep benefits of AWS, the serious cost savings, the dynamic scaling, often come when you optimize or re-architect your app to use cloud-native services properly. If you just lift and shift an old, inefficient application, you might end up paying more than you expect because it's not using those rented resources well.
So lift and shift might just be step one, not the final goal.
Often, yes. It's a stepping stone. You get it to the cloud, then you start optimizing it for the cloud environment. You know, if we zoom out a bit, moving to AWS, it really tackles a lot of the old frustrations developers and businesses used to face constantly before the cloud era.
Like what kind of frustrations?
Oh, things like environment inconsistencies. You know, the classic, well, it works on my machine bug.
Ugh, yes. Heard that one many times.
Right. An app works locally, but breaks on the server because of tiny differences. Also, complex server management. Setting up physical servers, maintaining them, that needed serious expertise, lots of time, tough for small teams. Then there were scalability limits, need to handle more users. That meant buying more servers, configuring them. It was slow, expensive, painful.
Definitely not agile.
Not at all. Downtime risks, too. Physical hardware fails, power goes out, your app goes offline, customers get angry, and the high costs involved in just owning and running all that hardware, especially if your traffic was unpredictable. Plus, big security challenges, setting up firewalls, managing encryption. It was complex, easy to get wrong without dedicated security staff.
Okay, that paints a pretty clear picture of the bad old days. So how does AWS specifically fix these issues?
It tackles them head on. For consistency, AWS gives you standardized environments. That works on my machine problem, mostly gone. It hugely simplifies management. AWS handles the server patching, the backups, the hardware stuff. Developers can focus on code.
Right.
For scalability, services like Elastic Beanstalk or auto-scaling let your app scale up or down automatically, instantly. Effortless scaling, really. Reliability gets a massive boost from those global data centers and automatic failover. Much less downtime.
Okay.
Costs become more manageable with pay-as-you-go. You're not paying for idle servers nearly as much. More economical, especially if traffic varies. And security is significantly enhanced. AWS has tons of built-in tools, firewalls, encryption, identity management like IAM. It makes securing your Spring Boot app much more robust and, frankly, easier to manage correctly.
Okay, it solves a lot of past problems. But why is this specific migration Spring Boot to AWS? Why is it so critical now, like right now in 2025?
Okay.
Feels like more than just convenience.
Oh, it absolutely is. The whole tech landscape has fundamentally shifted. First, just look around. Cloud computing dominance. AWS, Azure, Google Cloud, they power almost everything now. Startups, huge enterprises like Netflix. Everyone's on the cloud. AWS provides that essential foundation, scalable, reliable, that modern Spring Boot apps need to serve users globally.
So it's just where software lives now.
Pretty much.
Yeah.
Think about our Swift ship example again. Maybe they containerize their Spring Boot app with Docker. They can run that on AWS ECS, the Elastic Container Service, and it scales beautifully when package volumes spike. Second, microservices architecture is everywhere. Lots of Spring Boot projects are built as these small, independent services.
Right, break the big app down.
Exactly. Maybe SwiftShip has one microservice for user logins, another for updating package status. AWS is perfect for hosting these. Services like ECS or EKS, which is for Kubernetes, let each little service run efficiently and scale independently. Third, speed matters. Rapid development and deployment. Businesses need to get features out fast.
Stay competitive.
You got it. AWS tools simplify deployment dramatically. SwiftShip could push out a new feature for their tracking app in minutes, not days or weeks. That's a huge advantage. Then there's global scalability and reliability. Think about huge social media apps or e-commerce sites. Millions of users worldwide all at once.
Yeah, massive scale.
AWS's global network, plus services like Route 53 for smart traffic routing, means your Spring Boot app is fast and available for users in London, Tokyo, Sydney, wherever they are. Fifth, cybersecurity and compliance. This is huge now. Threats are rising, and regulations like GDPR for privacy or PCI DSS for payments are strict.
Can't mess those up.
Absolutely not. AWS provides critical tools, identity management, encryption, audit logs that help you secure your app and meet those compliance rules. Essential for SwiftShip handling customer addresses and tracking data. And finally, don't underestimate the impact on developer productivity and the job market, because AWS handles so much of the infrastructure complexity.
Developers can just code more.
Exactly. They focus on building features, solving business problems, not managing servers. And this shift has created enormous demand for developers who know AWS, who know cloud migration. It's a key skill employers are actively looking for.
Okay, that makes the why now very clear. Can you give us a few more concrete, real-world examples, maybe companies or types of apps listeners would recognize that are likely running Spring Boot on AWS?
Sure. Think about e-commerce. Amazon itself is the classic example. They run countless Spring Boot services on AWS to handle everything from the shopping cart to order processing. And think about how they scale for Prime Day.
Right. Unbelievable scale.
Streaming services. Netflix is famously built on AWS using microservices, many likely written in Java with frameworks like Spring Boot. That's how they deliver smooth video globally to millions simultaneously. Finance. Banks, fintech companies that use Spring Boot for critical applications like processing transactions or managing accounts, deployed securely on AWS using services like RDS and EC2, often needing to meet very strict compliance.
Makes sense for security and reliability there.
Definitely. And startups. Like our SwiftShip example, a small team with a great idea for a delivery app. They use AWS Elastic Beanstalk to launch quickly and scale as they grow, without needing a massive initial investment in hardware or a big operations team. It really does level the playing field.
So for you, the listener, maybe you're intrigued by this, maybe thinking about learning it, pivoting your career even. What's the advice? Is this actually doable for someone new to cloud?
Yes, absolutely.
Yeah.
It's definitely approachable, maybe more now than ever before. First step, learn the basics. Go to the source. AWS on Amazon.com has great tutorials. Or check out places like Free Code Camp. Focus initially on core services like Elastic Beanstalk or EC2. They have clear learning paths.
Okay, start with AWS fundamentals.
Yeah. And at the same time, explore Spring Boot. The official site, spring.io, has guides. Baildung is another fantastic resource for practical Spring Boot tutorials. Get comfortable building simple Java apps first. Then, crucially, build simple projects. Don't just read, do. Create a basic Spring Boot app, a to-do list, a simple blog, and then try deploying that app to AWS Elastic Beanstalk.
Get your hands dirty.
Exactly. That hands-on practice is where the real learning happens.
Mm.
You'll hit problems, figure them out. That's invaluable. Also, use the tools available. Spring Initializer, that's start.spring.io, makes creating a new Spring Boot project super easy. And definitely take advantage of the AWS free tier.
Ah, the free tier. Good point.
Yeah, it lets you experiment with services like EC2, RDS, S3, Elastic, Beanstalk without spending money while you're learning. It's fantastic. And finally, join communities. Don't learn in isolation. Stack Overflow, Reddit forums for AWS and Spring Boot. These places are full of people asking questions, getting answers, sharing knowledge. Use them.
Great advice. Okay, so we've really gone deep today. We've demystified moving Spring Boot to AWS. We've walked through the steps, seen how it works. We've uncovered those huge benefits: scalability, cost efficiency if you manage it right, reliability. We pinpointed the old problems it solves, environment drift, server headaches, and we really grasped why this is just, well, essential knowledge in 2025.
Yeah, it's become fundamental.
Learning this isn't just about shuffling code around. It genuinely opens doors. It lets you build professional, scalable applications that can reach anyone, anywhere. It prepares you for a tech world where the cloud isn't just an option, it's the default. So as you think about your own path, maybe as a developer, maybe starting a business, or maybe you're just curious about how the digital world actually runs, consider this. How might mastering this skill, moving applications to the cloud effectively, not just let us build better software, but maybe fundamentally change how we approach deploying and scaling any new idea in this digital age? Something to think about.